Hi everyone, my name is Miss Myra Trujillo. I'm part of Gear Up and I'm here with Mr. Miller.
Hello.
We are going to talk about multi-step equations.
All right, that sounds good.
So when we learned how to solve equations, we started with backtracking. So let's do some practice on that.
Okay.
So in order to solve for x, let's do our table here.
Backtracking is great. Actually, once you get it, it's easy to remember.
Okay, so 3 and x are being multiplied, so it's times 3, and then 9, you're adding 19. And we put the 40 down here. So remember backtracking. So the opposite of plus 19 is minus 19, and then divided by 3.
So we're undoing the steps. So we're starting with a number, multiplying by 3, adding 19 and getting 40, and then we're going to go backwards. All right, so I have a 40 minus 19. You got to remember to hit equals after every step. Then divide by 3. Miss Myra, I get 7.
Nice, me too. I got 17.
Okay, cool.
All right, let's do one more problem. So remember x up here. The x and the 7 are being divided. So divide by 7. Minus 12. Get 31. So let's do backtrack. 31 plus 12 times 7.
I get 301.
Me too.
So the good news is people who's backtracking get this one right almost all the time. They don't freak out. They realize that x over 7 is x divided by 7.
Yes.
And it's no big deal. Okay, now the new stuff.
Dun, 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 dun. Okay. Besides backtracking, we have another way of solving this. So if you notice here, there's x on this side and there's also x on the other side of the equal sign. So let's try to make this a little easier. Let's put all of the x's on the left side. So in order to move this 2x, I have to subtract it from the x as well. So 4x minus 2x gives me 2x. Then I bring down everything else. And then here, we can go ahead and try our backtrack.
Okay, yeah. So after we cancel an x term, it's back to the same old stuff. So I like how you cancel the x term, subtracting 2x on both sides. Because the basic rule is whatever you do to one side of the equation, you have to do to the other.
Yes.
So if you subtract 2x on one side, you have to subtract 2x on the other.
So 6 plus 7, now divided by 2.
Gotcha. Uh-oh, I get a decimal.
I got 6.5.
So did I.
Okay, good.
That's not too bad. Decimals happen. Very good. And you can always check your answer by going back, putting it into the equation. You put 6.5 in for our x. It should make both sides equal.
Yes, it should. That's how you check your work. And then let's try another problem. So again, you have x's on both sides, so let's go ahead and transfer this 3x to the other side. So positive 3x minus 3x on both sides, because Mr. Miller said, you want it to have it equal. Okay. So these cancel out. What I'm left with is 10. Negative 2x minus 3x should give me, negative 5x.
Yeah, there you go.
35.
So you might wonder if it matters which one you cancel. Actually, you can cancel either one of them.
That's true.
Just be careful with the signs. Like here, negative 2 plus negative 3 is negative 5.
Yes.
Okay, now?
Now let's do backtracking again.
All right. Now this is one you got to be really careful about. There's this type of equation, backtracking, because a lot of people think the 10 is being subtracted, but it's not. It's the 5 that's negative.
Yes.
So we're multiplying by negative 5.
And then we're adding 10.
Yeah, very good.
So backtracking means we do the opposite. So it's going to be 35 minus 10 divided by negative 5.
And I get -5.
Me too.
Alright, good.
Right, awesome. So let's try a geometry problem, Mr. Miller?
Let's do example A, and
Okay.
we'll cancel off B, so we'll give them a little bit of a break.
Alright,
Let's
sounds
do
good.
one more, because this one, sometimes when it's just minus x, like on the right-hand side, we don't know what to do, but just think of it as minus 1x.
So whenever you see minus x by itself, there's an imaginary 1 here.
Right.
Okay. So let's go ahead and move this x to the left side. So in order to move it, it's minus 1x, so the opposite of that would be to add 1x. Whatever I do to one side, I do to the other. So 1x. This cancels out. And what I'm left with is 44 plus 14x equals 16. Then let's solve for x by backtracking. So I have positive 44 times 14.
Oh, we have to do times 14 first.
Oh, the first times 14, right?
Yeah.
That's my mistake.
I'm sorry. Oh, we caught you earlier. I'm just already here with my calculator.
Okay, so let's do the times 14.
There you go. This is an order of operations.
Good catch, Mr. Miller. Okay.
I won't even mention that I first learned algebra in 1979. How's that for old?
Alright, so 16 minus 44 divided by 14
Gotcha.
equals,
-2.
do you have negative 2?
You don't have -2?
I had positive 2, but I might have missed the negative. Let's check our work again. So 16 minus 44 divided by 14.
Yeah, so 16 minus 44 is going to be negative, and we divide by a positive.
It should give you a negative.
Alright, we're good. Let's forget about that one.
Okay. Let's
And
move on to geometry.
alright, hang in there. We got 2 examples left. Alright, and they're both kind of similar problems from geometry, but since this is geometry, we want to apply it. We have right here we have a triangle, and that's an isosceles triangle. These two sides are marked the same, so this one is x also. And we have a rectangle here. This side is x, and this side is x plus 6. So here's the puzzle. We want to know what value for x would make the perimeters the same. So normally we don't write all this out, we'll just go straight for the equation, but since this is our first time doing it, we want to write out what the perimeter of the triangle is. So we're going to add up the sides, x plus 26, and we're going to combine like terms. So it's 2x plus 26. Sometimes we can just do that from the figure. Just go around and add up the x terms, and then add up the numbers. Alright, for the rectangle, maybe I'll do that. We have 1x here, there's 2, 3, 4 being added together. 4x. Then I'm going to go around and add up the numbers. I have a 6 here and a 6 here, that's plus 12. So I have the parameters of these two shapes, and the goal is to set them equal. So this is where we usually start. We usually just kind of write the parameter of the first one and set it equal to the second one, 4x plus 12. And we get, it's all algebra now, this is just what we were doing. So we're going to subtract 2x from both sides. On this side I have 26. This side I have, 2x. Scratch it out. 2x plus 12. Okay, so I'm going to backtrack. Wow, I'm running out of room to go here. I better make this kind of small here. And this quick. There's x. We're multiplying by 2. We're adding 12. I'm sorry if that's hard to see. We get 26. We'll do 26 minus 12. That would be 14. We're going to divide by 2. I get 7. Wow, all of that. So x equals 7. Now that's quite a problem. So we'll go through it again. But basically, we're just finding the perimeter for this by adding the sides, setting it equal to the perimeter of this, what we get when we add those sides. After that, all algebra. All right, Miss Myra, you ready for your turn?
Yes.
All right. Here we go.
Right, so let's do another geometry. So let's go down here. So here's another one. So find the value of x that would make the perimeters of the shapes equal. So perimeters, adding all the sides. So x plus 2 is this side. And it's a square, so we know that all of the sides are the same. So that means that this side, it's also x plus 2. So I'm going to go ahead and write x plus 2 for all sides.
Very good. And I really recommend that. I know I did that in the last problem, but I don't think I mentioned it. So I think it's good practice to kind of label all the sides so you don't miss anything.
So this is a rectangle, and we know that this side and this side are the same. So x here and x there. If this side is 16, that means the top one should be 16 also. So find the value of x that would make the perimeters of the shapes equal. So let's go ahead and combine like terms here. So how many x's? 1, 2, 3, 4. 4x. And now combine the numbers. 2 plus 2 plus 2 plus 2. 2, 4, 6, 8.
Yep.
Set it equal to here. So the x's. We have 2 x's. And then if we add the 16s, 16 plus 16 should give us 32.
That was the geometry part?
Yes.
The rest is algebra.
So now let's do the algebra. Subtract 2x. That should give us 2x plus 8 equals 32. Now let's backtrack. So we have the x there plus 8 is 32.
Alright, I'm ready here.
So 32 minus 8 divided by 2 should give you
12.
Nice. There we go.
It works.
And if we plug it back in, the perimeter should be the same.
Myra, I have a question to ask you before we finish. You're a biology major?
Yeah.
At NEIU?
Yes,
Do you use math in biology?
All the time.
What kind of math?
Algebra, calculus, all that.
Any statistics?
Yes, statistics too.
Awesome.
So it's gonna come in handy.
Alright. Biology
Definitely.
is a really cool subject. Okay, here we go. Here's today's journal assignment. So we've got 3 problems. The first 2 are just solving the equations, so copy them. Make sure you label the video as video 1H. And the last one is geometry. Okay, so copy the figures and then write an equation for the third one. And find which value of x will make the perimeters equal. Alright, Miss Myra?
Yes.
See you next time. Bye, guys.
Bye.